Hello from Intellipaat guys. The topic for today is Apache Spark with Java. But before we begin, be sure to hit that subscribe button and click on that bell notification icon so you don't miss out on any updates from us. So for the agenda, we have topics such as what is big data, the challenges that we face in big data analytics, and eventually the solution, which is Hadoop. And then we can go on to what Apache Spark is, the features of Apache Spark, ways to implement Apache Spark, and eventually the tutorial for Apache Spark with Java. So without any further ado, let us begin. What is big data? Data is the individual unit of information that is defined as figures or facts and stored for later processing. So data could be of three types essentially: structured data, semi-structured data, or unstructured data. Structured data is the one we find in SQL tables where you have particular column names and data assigned to those column names. And then we have semi-structured data, which is like CSV files and JSON files, which aren't exactly SQL tables, but they still have some sort of a structure. And then we have supposedly randomized data like unstructured data, which is JPG, MP3, PPT, PDF, and all of this data. Because there is no order to it, it could basically be in any order. So that is why it's called unstructured. So what is big data? So now that we know what data is, we can now understand what big data is. So big data has the word big attached to it, which means that these data sets are extremely large data sets. And these data sets can eventually be analyzed computationally to reveal trends, secrets, patterns, statistics that may be beneficial to us in terms of commercial success or just scientific research. So the examples of big data could be defined as black box data, which is basically flight communication data, flight statistics data. So basically, whenever you're going in an airplane, there's basically a black box in that airplane which records all of the flight communication and all of the flight statistics, flight monitoring in basically a data format. So this can be analyzed later on for understanding if there is any sort of mishap with the flight, or just in general analyzing the different aspects of flight aviation and whatnot. And then we have the most commonly used aspect of big data, which is social media data, which contains all of the data that we as users generate from our social media platforms, from our social media websites like Facebook, WhatsApp, YouTube. So we create our accounts, and whenever we create our accounts, all of the data that basically we generate with that, like the searches that we make, the kind of videos that we watch, the kind of activities that we perform on these social media websites, is basically logged in those social media websites. And this is basically in a large amount because there are millions and millions of users of these websites. So this can also be termed as big data. And in other similar examples, we have power grid data, transport data, stock exchange data, in order to understand like secret stock, hidden patterns as to what the trend of particular stock market is. And then search engine data, like if we are using Google or Yahoo search, so all of the searches that we make, they also account for certain amounts of data. So there are basically five criteria that need to be fulfilled in order for a normal data set to be called as big data. So what are these five V's? Basically, these are five V's that can be defined as velocity, volume, variety, veracity, and value, which contribute as the criteria for any data to be called as big data. So the first is velocity. So the speed in which the data is generated, is called as velocity. So this should be of a significantly higher amount than normally generated data. So for example, on Google, more than 3.5 billion searches are made per day. So Google searches can be basically fulfill the criteria of velocity, because on Google, basically, the searches are being made rampantly every day at a very high amount. So that qualifies for the velocity criteria for big data. And then we have volume. So this is the most obvious aspect for any data to be called as big data. The data should be really, really big in size. So for example, the estimated global mobile traffic was 6.2 exabytes which is equivalent to 6.2 billion gigabytes per month in the year of 2016. So this basically constitutes for big data because this is a large chunk of data in size. So obviously the second criteria that needs to be qualified in order for data to be called as big data is for data to have a really high volume. And then we move on to variety. So the data shouldn't come from a single source. The data could be coming from multiple sources, and that basically constitutes for variety. The data should be different in nature, should come from heterogeneous sources, not just a single source. So that would constitute for variety. So yes, the next point that we have is veracity. So the data can't be perfect. Because in exabytes and terabytes of data that we are accumulating, it is virtually impossible for the data to be perfect. There has to be inconsistencies in the data, there has to be errors in the data, missing values in the data. So that is basically a practical case, a practical scenario for big data, that the data cannot be error-free, fault-free. So the data needs to have veracity in order to be called as big data as well. And then we have values. So obviously the most important factor for any big data set, essential to be of any use in terms of analytics, is for the data to have value. So for instance, we have college data. There are certain columns in a college data which is like roll numbers or names. So these are not essential because names and roll numbers are not constituting any sort of actual statistic. It could be random in nature. So if we are actually accounting that as big data, no matter how much the data exists in volume, a roll number and names cannot be called as data of value, because those data sets on their own do not contribute to any sort of analytics because they are random in nature. But on the other hand, columns like grades and columns like marks, so these particular attributes can be accounted for big data, because we can use this sort of data to basically create analytics, statistics as to how students are performing. So yes, that is what constitutes for value, and that is the last criteria that we need to satisfy in order for any data set to be called as big data. So now that we know what big data is, let's move on to big data analytics. So what is big data analytics? Basically uncovering hidden patterns, hidden trends, statistical information, and performing large calculations on the data that we have generated, which we are calling as big data, for scientific purposes, for commercial success, and for any other purpose that you may have at a personal level or an organizational level. So every major organization today, like Facebook, Amazon, Apple, Microsoft, Google, all of these companies, all of these organizations have large consumer bases, and all of these organizations basically need this information generated by their consumer base in order to work more efficiently, target their audiences more efficiently, and cater to their audiences more efficiently as well. Because the data that is generated by their consumer base helps these organizations in order to understand what the consumer wants. So every major commercial organization harvests this big data in one way or the other. And this data might just not be used for commercial purposes. This might be used for scientific purposes as well, in order to understand environment, climate change, and everything that basically can be termed as big data has one particular use. So the advantage of this is the usage of big data in today's world has made a very direct impact on profits and customer retention as well. So we find ourselves subconsciously sticking to these websites like Amazon and Instagram without even realizing what makes us addicted to them. It's because the customer service, the customer experiences that these websites provide to us are handmade, basically catered to us according to the models that they've created using the big data that they have. So that is why it is financially profitable for them to do big data analytics, and customer retention is higher than ever. So why is big data analytics important? 4 points essentially: personalized customer experience. So the experience that you get is personalized, is handcrafted for you based on other customers that are behaving the same way as you on a particular website. Say for instance, if I bring up YouTube, I watch a particular video on YouTube, and then immediately after watching that video I watch some other video on YouTube. So that data, that particular activity of mine gets recorded by YouTube. So over time, if people are doing the same thing as me, say if a lot of people are gravitating towards watching the same video as I did, so that basically creates a model that basically trains the YouTube algorithms. And say if a new a new customer comes, a new viewer comes to YouTube, and he also watches that particular video that everybody else watched would be recommended to him. And surprisingly, in 9 out of 10 cases, that is exactly the video that the other person would be looking for. So human brains behave in a similar pattern, and analyzing this particular data helps us understand what we as customers are looking for. So that is why it constitutes for a personalized customer experience, the big data analytics. Then we have showing of only relevant data. So for another case, we can bring up YouTube. If we are searching for gaming content, or if we're searching for scientific content, chances are that save a few results, most results that we would get in our YouTube's homepage would be the sort of content that we are actually looking for, and not any randomized content. So showing of only relevant data also is a additional point over personalized customer experience. And targeted advertising. So for these websites, these huge commercial organizations to profit, they basically analyze what we like on YouTube, what we search for on Google, and what we basically look for on Facebook, like the pages, and what we basically are interested in. And based on those interests, based on the genres of our interest, they target particular advertisements to us. So a lot of people, a lot of organizations, they pay for ads on Google or YouTube or Facebook. So Facebook basically gets the money for these ads, and the aim for Facebook now is to target these ads to the customers that are the most likely to click on these ads to actually conduct business with these ads. So in order to do that, Facebook basically, or any website basically, analyzes your big data analytics patterns and targets those particular products towards you. And then obviously we have our scientific facet, which is research and technical analysis. So in the fields of science, in the fields of environmental studies, in the fields of mathematical analysis, big data analytics is also important. So that is also one use case for it. So the challenges that are faced in big data analytics. So big data analytics, data with high velocity, high volume, basically means that we need a lot of hardware resources to analyze this data. This is not a simple RDBMS table that we are analyzing of a few MBs or a few KBs. This is a large chunk of data, like it goes up until exabytes and terabytes. It could go higher and higher. So we need high level hardware, a lot of hardware essentially, to analyze this data. So the problems that we face with this is hardware failure. So when we are using these large servers that are used to analyze this data, in the case of a server becoming non-functional or a server failing, we can essentially lose all of the data, the enormous volumes of data, or we could be stuck in between the processing of this data and lose all of the progress that we have made in the creation of our big data analytics model. So in order to combat this, we need some solution. The first problem that we face with big data analytics using traditional methods is hardware failure. The second is combining. So other solution that comes up for this is using distributed system. So distributed systems essentially helps us in order to basically store this large amount of data on different systems rather than just one server, right? So when we combat the issue of hardware failure by using distributed systems, we need all of this data, these terabytes and terabytes of data that are present throughout different nodes on a distributed system to be combined in order for us to view them, in order for us to have them in one place so that we are able to analyze them, or we are able to view them or process them. So this combination requires a lot of input-output operations, which again requires a lot of processing power, requires a lot of time. So that is another problem that we have with big data analytics using traditional methods, which is combining of this data. Then the solution that we have for this is, for hardware failure, we can use something we call as data replication. So say that one particular node in a distributed system fails, which contains one copy of a particular data. It doesn't really matter as long as we are fixing that one particular node. The data has not been lost, because the data has been copied like 3 or 4 times and replicated on other nodes of that distributed system. So this is done using the Hadoop distributed file system, which we call in short form as the HDFS, which creates multiple copies of the data. So in the case of a node failure or a hardware failure, the copy of that data still exists. So this is the solution for hardware failure. Then we have the solution for combining data. So MapReduce in Hadoop basically gives us a programming model that abstracts the problem of reading and writing this data in order for it to be combined. So what does it do? Rather than actually bringing the data from the nodes to where we are trying to process it, this MapReduce model pushes the code to that node. So the data isn't transferred. The code that we are using to analyze that data is transferred to the node where we need to transfer it. So this significantly reduces the input-output threshold, the input-output criteria, which we are basically using in order for data to be analyzed. So this reduces the overhead of our server by a significant margin. So now let's just move on to what is Hadoop. So Hadoop is a platform that we are using currently in a lot of places for big data analytics and basically storing big data, processing big data. It's a solution for us to manage distributed file systems in a really efficient manner and analyze the data in a really efficient manner, decreasing the overall threshold that goes into a particular system or a server or a cluster. So the goals for using Hadoop are basically being able to analyze both structured and non-structured data, and being able to use simple programming models, nothing fancy, nothing based according to a distributed file system, basically using simple programming languages, simple programming statements, the ones we would use for analyzing normal data sets, not just big data sets, and simply abstracting the job of handling a distributed file system where we are analyzing big data by just implementing it in the background, and the programmer only needs to concern himself with actually implementing a way to analyze the data like a normal data set. So the way we do it is by using HDFS. So very large files are analyzed, streaming data access, and the best part of HDFS is the use of commodity hardware. So we're not actually using industrial level hardware or industry grade hardware or very expensive hardware. We're basically using commodity level hardware, which is the normal hardware that we have in offices, the normal computer systems that we use. So computer systems are basically converted into nodes, so people can simultaneously function while a certain amount of the system is dedicated to the Hadoop cluster, a certain amount of the system can be dedicated for personal use, and we can simply keep on adding nodes of this commodity hardware in order for us to increase our capacity and threshold, and we can do it at a much cheaper cost because we don't need to buy specific hardware for big data analytics. Then we have our MapReduce, which is the core component for the Hadoop ecosystem. It is a software framework which helps us implement big data analytics on distributed systems using parallel algorithms. So all of the nodes will execute a particular query or a particular processing instance in a parallel way, so that time is saved and multiple machines can be running on the same cluster and doing the same job and doing it in a much faster way. So there are basically two components to a MapReduce, as we can see in the name, which is the mapper and the reducer. So all of these things basically imply that the mapper essentially works in parallel, assigns values to particular keys after it has broken down the data. All of the mapper jobs are independent of each other, and once the mappers have finished assigning values to keys and have after the mappers have successfully created key pairs, the mapper sends their data to the reducer, and the reduction happens where the data is essentially aggregated, the values are aggregated, and we get our final result. So what is Apache Spark? So in the Hadoop ecosystem, while we are using the HDFS, a very robust way of using a distributed file system for storing big data and processing it, we use a component, we use a framework which we call as Apache Spark. So the Apache Spark framework is like 100 times faster than traditional Hadoop MapReduce. So a little bit of background history on Apache Spark. It is an open source cluster computing framework for real-time processing. So the cluster is our Hadoop cluster, and Apache Spark is a framework that basically acts on top of our Hadoop cluster in order for real-time processing. So it was introduced in UC Berkeley in the Research and Development Lab in the year of 2009. In 2010, it became an open source software and open source framework, and it was eventually donated to the Apache Software Foundation, the Apache Hadoop, so basically Apache Spark now, in 2013, and became the top level Apache project by the year 2014, even surpassing the Apache Hadoop MapReduce framework. So the features of Spark. The first feature is real-time computation. So basically, when we are using Apache Spark, we are transferring the data that we need to process into our memory. So that basically means that we are processing that data in real time and low latency, because we are not fetching that data, we are not going towards that data, we're bringing that data in memory. So we can basically compute that data with almost zero latency because it is within our physical memory. Then generality. So the syntax for Spark is pretty easy. So if you are familiar with SQL, you can understand Spark instantly because it isn't that different from SQL. So if you're familiar with querying SQL tables, operating with Spark SQL is not that difficult. So there are basically these complex analytics and streaming that can be done on big data using simple methodology, simple syntax. Without you having to learn some sort of a very complex language, you can do it pretty easily. So that is what generality means. Speed, 100 times faster than your common Hadoop MapReduce framework because we are transferring the data in memory. So basically zero latency and real-time computation. Then we have deployment, easy to deploy. So if you have a Hadoop cluster setup with the Yarn as the resource management application, we can use the Yarn or we can use Spark's own cluster manager. So deployment of Spark is pretty easy. Then the ease of use. So basically, if you're familiar with any of Java or Scala or Python or R or SQL, you can basically understand Spark pretty well. Spark provides APIs and libraries for these particular languages that I've just mentioned. So you can basically import those libraries in your code and basically write your Spark code using any of these 5 languages or frameworks like Java, Scala, Python, R, and SQL. And then we have powerful caching. So basically it surpasses the disk persistence capabilities by performing you with caching. So it increases the overall speed, it increases the overall efficiency at which you are processing your data, analyzing your data using Spark. So now that we have discussed the features of Spark, we will now understand the ways to implement Spark, which we just discussed in the ease of use. So you can basically implement Spark using one of these 5 components, one of these 5 entities. So if you're familiar with Python, which is the most popular way to implement Spark, by the way, so a lot of data scientists, data analysts use Python. If you're very well aware, I'm sure you're aware. So Python has a very simple way of integrating with Spark. So you use the same code base as you would use for normal data analytics using Python, but once you are importing certain libraries from Spark and creating a Spark context, you can use the same exact coding methodology but operate on big data without having to learn anything new. So that is one of the advantages of using Python with Spark, which we also call as PySpark. So then we have Java. So if you are from an old school coding background, if you are familiar with Java, if you're not into Python, if you're not into big data analytics using Python, you can basically use Java and import certain Spark libraries and get started with your code. And the first and foremost way to implement Spark, which is the most traditional way to implement Spark, if you actually start Spark shell in your terminal, it actually starts with a Scala shell. So basically you can write, by default Spark uses Scala, but you can override that, you can use Java as well. But if you're just starting up a Spark shell, you would be using Scala. So if you're familiar with Scala, you can use Scala as well in order to implement Spark code by importing certain libraries. Then we have R programming. So R is also compatible with Spark. So R is also another way of data analytics. You might, if you are from a data science or data analytics background, you might be familiar with one of these two, like Python or R programming. So one of these two languages you must be familiar with. So it is easy to integrate that with Spark as well. You use the same code, you use the same functions, you use the same commands, but just by importing Spark libraries, you're basically running your queries, running your analysis on big data in a much more efficient way. And then we have Spark SQL. So if you're not from any of these backgrounds, if you're just from a database management background, you can use Spark SQL, run normal SQL statements. It's pretty easy to get familiar with using Spark SQL. So those are the ways in which you can implement Spark in your code base, in your big data analytics field, basically using one of these 5 languages. So now that we know all of the ways in which we can implement our Spark framework, we can basically begin with coding, right? So one of the ways in which we can implement Spark is with Java, as we discussed before, and now we will begin with the tutorial. So firstly, we would be installing Java and Spark on our Windows system, and then we would be going over to our Eclipse IDE and actually starting with our code. So let us begin. Wait for it to install. So once that is done, we'll go over to set our paths for our Java variables. Simply type in system environment variables. So once you get that, you'll already get this particular best match in your start menu. Click on it. So a pop-up will basically come onto your screen. System properties, go to environment variables, and then you'll have something like your user variables for your user account and your system variables. So I'll simply click on edit for my user variables, and I already have this Java home, which is predefined, preset. But if you don't have it, you can simply click on new and type in Java underscore home and given the directory for your JDK folder. So in my case, the JDK folder is nc program files Java slash JDK 14.0.2. So right over here. So this is the directory that we're actually giving to our home. So it might be different in your case depending on where you've installed Java. In my case, I've installed Java and C drive program files Java. So once you've done that, we'll now go over to the path in our system variables and simply click on edit. Once you've clicked on edit, simply give in your Java path in the edit option. So right now we already have our bin folder set for our Java, but in case you don't have it, simply click on new and given this particular address after JDK 14.0.1/bin. So that is pretty important. So once you've done with that, you're basically set up with Java. Now let's go over and search for Apache Spark because we would need that in order for our code. Simply type in Apache Spark in your Google search bar. And let's download version 2.4.5. So for that, we'll simply open up Apache Spark's website and search for download. And then we have our 2.4.5 because that's the stable version. Don't go for 3, go for 2.4.5. And simply click on download Spark 2.4.5 bin Hadoop 2.7 TGC. So you can click on this mirror link in order for the download to start. So as you can see, it's a relatively large file, around 200 MBs. So wait for it to download. Alright, our Spark is now downloaded. Now we will begin with installing Spark and setting the environment variables for our Spark. Simply extract our Spark folder that we've downloaded by clicking on extract to. Once we're done with that, simply rename this to something simpler so that we can actually add it in our environment variables. We could call it Spark. So once we're done with that, simply copy this and paste it in your C drive or any directory that is more accessible. So wait for it to actually finish copying. So we'll open up this folder and we see another naming scheme again. We'll simply change this to Spark as well. Should have just copied this folder, and once we open that, simply copy this address that we have here. Once you've copied that, simply open up your system environment variables once again. Scroll over to your system variables, create a new variable, call it Spark Home. Spark _home and paste your address. Once you're done with that, go to the path variable, search for the path variable, edit it, add a new entry to this, paste the address that you had copied from before, put a single backslash again, add in bin because the executable for Spark is inside the bin folder, which is our Spark shell. Press OK and OK, that would about it. That is about it. That would set the environment variable for our Spark. Now let's search for a file, an exe file called winutils, because we would be needing to set the path to winutils.exe in order for our Spark code to run. Simply type in winutils in your Google search bar. Press enter. Then you'll get this GitHub link. Be sure to click on this exact GitHub link. Search for Hadoop 2.7.1 because that is the version that we downloaded our Spark for. Click on bin, then search for winutils.exe and click on download. So once you download that, you will get this winutils.exe downloaded. So here we have our winutils.exe file. We will simply copy this, create a new folder inside of C drive. We'll call this winutils. Open that up. Create a new folder which we will call bin. And within bin, paste the exe file. Now we will set the path to this winutils.exe. So open up your system environment variables once again. Scroll down to system variables, create a new variable which we will call Hadoop _home, and the value would be the address to this winutils, not up until bin. up until WinUtils. So once you've done that, open up the path variable as well, edit it, add a new entry into it, and paste it, and put a backslash and add bin, because our executable inside the bin folder, and that is the path that we need. And press OK and OK. So now we've set our path to our WinUtils as well. The next step is to install Apache Maven. So we will search for Apache Maven in Google and open the first result, that is from the Apache website. Search for the download option, click on it. And after we've searched for it, search for the download option, simply search for the link that we need to use in order for us to download Maven. So we will be using this. Once that is installed, click on Show in Folder. So we have our Apache Maven right over here. Simply extract this. After it has been extracted, rename this to something simple like Apache Maven. After that is done, actually we will rename this as well. So simply copy this folder, put it in your C drive, paste it. Once that has done pasting, open up the directory, copy this address, and now set path for our Maven home. So open up our system variables once again, go to environment variables, create a new variable. We will call this Maven underscore home, and paste our directory. Search for our path variable, path system variable. Where do we have it? Open it up. Add a new entry to this, which we already have, like right over here for our Maven. So if you already have it, you don't need to do it again. So once you're done with that, you press OK and OK, and then you're set with your Maven directory as well. So once that is done, the next step is to install our Scala IDE as well, because without that our Spark cannot run. So simply type in Scala -IDE.org in order to open up our website for our Scala IDE. So click on Download IDE. Simply click on Download Scala IDE. And click on this. Depending on the version that you have, it will take some time to download 270 MBs. So now that we have it over here, extract this. Open up this folder and simply install this with our Eclipse opener. In order for us to use our Spark code, we need to open it using this and launch the workspace. So now we can start with our coding once the workspace has been launched. Okay, as we can see, the workspace has been launched. So we can now begin with writing our first Spark program using Java. But before we actually begin with our code, we need to start our virtualized distributed file system cluster. So the first thing that we would do is create our master node. So for that, we'll open up Spark, the folder which is there in our C drive. Once we've opened that, copy this directory, open up our command prompt. Once we've opened up our command prompt, we will then change our directory to this. Once we are done with that, we'll just HDFS. Yeah. So we will now start our Spark master node. Simply type this alongside me. Type in the package name. And press enter. Wait for your master node to start. It'll take some time. Allow access. So our master node has now been started. Now we will start a worker node. So as we know that a Hadoop cluster or a distributed file cluster has master and slaves. So we need to start another CMD and change the directory to yet again the Spark directory. Now we will start a worker node. To get the local address for your Spark master node, just open up your browser, type in localhost :8080. So our Spark is open at this particular address, so note that address. So be sure to copy this. Once you've copied that, we will now start our worker node as well. So for that, simply type in Spark -class org.spark.deploy. Since we're deploying our worker node, type worker again for the class name, and then given our address because that is the address of our master node, and press enter. So that will start our worker node as well. Little error there. I forgot to add in the correct class name. The correct class name would be org.apache.spark.deploy worker. So that should work correctly. And press enter and wait for it to execute for our worker node to start. So as we can see, successfully registered with master Spark. So we've created a worker node. If you just refresh the page, we will see that a worker ID has been generated. So we have also created a worker node in order to execute our statements. And just to check if our Spark shell is running with our master node, we'll simply open up another CMD. Change this to the address that we have, which is C:\spark. So once that is open, simply type in Spark -shell -master, and then given this particular address that you have for the master node, and press enter, and a Spark shell should start using that particular master node. And when we refresh this particular page, we should see that update in the running application section. So as we can see, our Spark session is now available. If we refresh this, we will now see that we have our running application as well. So now with all of that done, we can now begin with our coding. So let us begin with it. So the first thing you need to do is start up your Eclipse and then go to File, click on New, click on Maven Project, and click on Create Simple Project, Next, and then add any group ID. I'll add Intellipaat. Artifact ID, you can add anything. I'll add 1 in that case, and I'll add name as word count because we're going to be doing a word count program. And click on finish so that the project is created. Okay, we have our project right here. The project is called 1, and within this we first need to resolve all of our build path dependencies before we actually begin with our coding. We need to import the packages that we need to add them to our build path. Right click on JRE system library, click on build path, configure build path, go to libraries, click on add external jars. Now we will search for our Spark folder. Open our Spark folder, then we have our folder called jars. Open that folder up. Control A, select all of these jars because any one of them could be needed. Open it up and apply and close. Now our build path dependencies have been resolved. Now we will start with our coding. So right click on the SRC folder, click on new, click on project, click on other, search for Java, click on class. Once you find Java, click on class. Once you've opened up the class, we'll start something called word count. So this could be word count.java. So once that has been done, click on finish. So we create our Java file. So firstly, we need to import our packages. This first package we need to import is import or.apache.spark config. Put a semicolon over there, and then we need to import the RDD, the Java RDD package, which is import or.apache.spark.api.java pair RDD. Once you import that, I think it's not config, it's conf, by the way. That should throw an error. The next import is import org.apache.spark.api.java RDD. So a simple Java RDD. And then simply copy it up until there because the next import is Java Spark configuration, which means Java Spark context. It's because we need to create our context variable using Java, and then import Scala.tuple because that would be our final data output format. And obviously for our basic Java functionalities, Java utils.arrays because we will be using arrays. And then we will begin with our class name. We'll call this class word count, as same as the Java file name. Start our function, create a function for our word count. We'll call this public static void. The function name will call it simply word count, camel guessing. Although it's not syntax important, but we can still use it. And the file directory that we will be using for this, which we will call simply file name, a string value. This is the file directory, the input file directory. And under this, we will now start with our coding. First, we create our Spark configuration variable to start our Spark context with. Create an object for that. New Spark and set master as local and set an app name. This could be any app name you want. Call this word counter for now. We need to use this configuration object to create our context. So Java Spark context. It's a random variable to store our Spark context in. New Java Spark context, and within this we will send our Spark conf variable because that is containing our configuration values like the application name and such. And we create an RDD Special thing about Spark is we can use RDDs, and usually it's done using Scala, but right now we're using Java. String RDD and an input file. Camel case name important, and use Spark context value, the variable that we have, and a text file because the input data source will be a text file in our case. And we'll close that up. Now we will create another RDD to store all of the separate words in our text file into. We'll use the input file variable for this. That's where we're storing our entire text file RDD into, and we'll perform a MapReduce on this by using flat map. Create some random variable, map it with arrays dot as list content. If we use our file name exactly right, actually it starts with a small f, so that should fix that up. Content dot split, we're splitting it wherever we see a space, so that delimiter is a space. Close this up, and once we've closed that up, we will simply add an iterator to that so that we convert it to an iterator, because that is what we're storing our values inside of. And close this up. And check this up again. Read string words from file equals to input file dot flat map content arrays dot as list, so getting them as list. Yeah, so the compliance needed to be changed. Then we will create our final output where we are mapping all of these words that we are separated. So the words from file variable, we're mapping it up. Variable for this, and a new tuple to store our information inside of. So we're mapping each occurrence of a word with 1 and reducing all of this by key. X, Y. Int X plus int Y, so this is explicit typecasting of the values X and Y. So once that is done, simply save this entire output as a text file. So there's a simple function for that, save as text file. Use that and add the path. For this, I'm going to use something called output file output path 1. So this will create a path in our workspace itself, our Eclipse workspace. And once that is done, the function has been created. We'll create our main function, public static void main. Create a string args so that we can give our file path input. Start our check. We'll first check if there is an input for our source file. If there is not, we'll simply write there is no source file input. So first we'll check if the args length is equals to 0. If it is equals to 0, I'll simply write system print ln, please enter source file address, close that up, and give an exit code of like system.exit of 0, so that you can know that there is an error. And then if that doesn't happen, if we don't system exit, we'll simply send this to our function, this particular value, this particular address of the source text file that we're using. So that is about it for the program. Now we will go on and execute this. So let us first enter the argument that we need, which is our source file, the data set that we're going to be picking up in order to perform the word count. So the address for that is C Shakespeare.txt. So this is the argument that we're sending, and then we'll click on run. So we'll wait for this to happen. So as we can see, the operation has been completed successfully. Now we will go ahead and check our output. So if we go to users and the user directory and find our Eclipse workspace and click on the project name, which was 1, we have our folder called output path, and we have 2 files right over here. The part 0000 is our output. We'll open this using Notepad, and there we go. We have our word count. So this was our word count using Spark with Java on our Windows system. So as we can see, our array has been created inside of this text file. So now that our tutorial session has ended, we now move on to the average salary of a Spark developer. So in the United States, it's around $127,000 per year, and for India, it is 11 lakhs per annum, and for the UK, it is 79,000 pounds. So Spark currently is the most popular tool for big data analytics. It's more popular than MapReduce, Big, and Hive. So if you're looking for an efficient way to get into big data analytics, if you're accustomed with Python or R, it's very easy to get into Spark. So I would recommend you guys to get into it that way using PySpark or R with Spark. Those are the 2 most popular ways that people from a data science background are getting into Spark. And that's about it for the session. Now we'll go over to some of the courses that we provide with regards to Spark, some of the courses that we offer. As we can see, an investment in knowledge always pays the best interest. So you can get a little bit of information from here and from there, but in order to get proficient at this Spark or any art for that matter, you need to have that knowledge in a more structured and organized format. You need to have practice in it. You need to have an industry level experience in it. You have to do industry level projects with it in order to get proficient with it. So that is what we provide to you at Intellipaat. So if you go over to Intellipaat.com, you can simply search Spark over here, and you get a lot of options with regards to Spark. We offer Spark in a lot of our courses. So we have our Apache Spark Scala Storm training, and other than that, we have our PySpark training course if you're looking to learn Spark from a Python background, from a data analytics / data science background. And then we have the entirety of our course, which is present in our Big Data Hadoop, Spark, Storm, and Scala course. So we'll just go over the Spark master course that we have. So let's look over that for a moment here. We open it up. As we can see, this course is in collaboration with IBM and Microsoft. And there are online classrooms available for this as well as self-paced courses. So the key features for this particular course is that this is an instructor-led training, so over 240 hours of live instructor-led training where you can ask for doubts. If you have any doubts throughout your sessions, throughout your live sessions, you can ask them. And then if the instructor is not going according to your pace, if he's going too fast or too slow, you have self-paced training lessons, which means that videos are pre-recorded. You can look over the videos and try to do your projects, try to do your problems at your own pace. And 480 hours worth of exercises, industry level project work, and then lifetime access to the course. So the course doesn't expire once you buy it, you always have access to it. And one of the other features that we give with the course is that every time the technology upgrades, a significant shift in that particular technology occurs, we update our course accordingly. So you get the new course for absolutely free. You don't have to pay anything for it. And then obviously we have 24/7 technical support and query resolution. So if you're doing some sort of an assignment, doing some sort of a project, if you encounter any issues with that, you can contact our technical support. We will help you, hint you in the right direction. You can get certified with global industry level recognized certifications, and then after you've completed our certification, we also provide you with job assistance. While we may not be able to guarantee you a job, we will certainly provide you with job assistance, get you the right interviews, forward your resumes to the right places. And obviously, if your schedule is not matching with the live lessons, with our schedule, the schedule is flexible as well. You can attend another session, you can join another batch if you missed some classes. So it's pretty flexible, to say the least. And then about the courses, we have this course content. The things that you learn in our Spark course is pattern matching, Scala collections, RDDs, data aggregation, the essential things that you need to know about Spark. As you can see, we also have our mlib and so on and so forth. We also have Python web scraping as well. So yeah. So you can go over here, look at our syllabus, and look at the certification criteria for this, the IBM certification that you will get after you've completed our certification. Look at some of the ratings and reviews given to us by our customers who've taken similar courses, and the comment sections. We also have frequently asked questions. So if you have any doubts, you can look over to the FAQs before actually contacting us to know if your doubts have been resolved or not. You can look over to the FAQs, see if the questions match yours. So yeah. I would highly recommend you guys, if you're industry level professionals, if you're looking to upgrade your job profile, to go over to Intellipaat.com, open up our Spark Master course, any Spark course that you would like according to your needs. Look over the course contents, look over the certification criteria, and just let us know if you like to participate, to enroll inside of it. So yeah, and especially for our YouTube audiences watching us here today, we are giving you a coupon code YouTube30s to get a flat 30% discount on not just our Spark courses, but all of our courses. So if you go over to Intellipaat.com, get one of our courses and use the coupon code YouTube30, you'll get a flat 30% discount on the entire price of our courses. So that is about it for our session here today. We've reached the end. You can contact us with the following contact details. You can contact us sales@intellipaat.com. You can chat with our course advisors if you have any queries. I'll leave these details onto the screen for you guys for a while to be able to note them down. So thank you for attending our live session here today. Goodbye from Intellipaat.